Let's begin. Today is August 9th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria card 4, 10, 13, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our middle digit, our square digit, and compares it to 4. So should the value of square be less than 4? Should it be equal to 4? Or should it be greater than 4? Criteria card B looks at the 3-digit solution and will let us know how many of those 3 digits are 4. Are there no 4s? Is there a single 4? Perhaps 2? Maybe even all 3 are 4. Criteria card C will look at our middle and last digit, square and circle, and compare them. So should the value of square be less than circle? Should they be equal? Or should the value of square be greater than circle? Criteria card D will look at our first 2 digits, triangle and square, add them together and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should it be greater than 6? And finally, criteria card E again looks at our 3-digit solution and will let us know a little bit about how it's structured. Specifically, one scenario is that there are no repetitions, meaning that all digits are unique, as in the example 125. Or it could be a double number, where there is a single digit repeated twice, as in the example 112. Or potentially it could be a triple number, where it's the same digit repeated 3 times, as in the example 222. Remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 5 criteria cards. And we're going to start off with an initial proposal of 314. So the first thing I want to find out is something about the structure of the solution. So let me go ahead and test criteria card E. Okay, so the Turing Machine does not approve of my proposal. Notice I do have 314, all unique digits, meaning there's no repetition, but that's not the case. So the Turing Machine is telling me that either I have a double number or a triple number. So let's go ahead and let's go update our notes in section E, that the solution is a double or triple number. Okay, so at this point we really can't cross out anything, so we move on. Next thing I'd like to test is, let's go ahead and test criteria card D. I want to know something about triangle and square. So let's go ahead and again test D. Okay, so again the Turing Machine does not approve of my proposal. Notice that I did choose a 3 for triangle and 1 for square. That sum is less than 6, but the Turing Machine does not approve of that. So it's telling me that either the sum of the first 2 digits is either 6 or greater than 6. So let's go ahead and update the notes on section D. And that again is that triangle plus square is either equal to 6 or greater than 6. Okay, and we really cannot cross out anything because 1 plus 5 does equal 6. That's still valid, and anything in between. All we really can say is that you're not going to have 2 small values for both triangle and square. Okay. And let's see, we also have this criteria card C that'll compare square and circle. So let's see. Yeah, let's go ahead and test criteria card C. Okay, another X. Well, what does this say? So I did choose a 1 for square and 4 for circle. So obviously the Turing machine does not approve of that. So it's telling me that either square equals circle or square is greater than circle. So let's go ahead and update our notes for that. And that again is that square is either, let's see, how am I going to phrase it? Let's do is equal to or greater than circle. Okay, and I think again, I don't believe I can cross out anything because they can be equal, and that could be our double number. It could be equal or square could be greater than circle. So we still don't know for sure. Well, that does it for this round. We did do our 3 Turing tests. Next, we're going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing the middle digit to the number 4, and of course knowing how many 4s there are. So it could be that we could have 2 4s. Who knows, right? We could have a double number. I'm trying to see if there's a way where we can eliminate the triple number. Is there a way to eliminate the triple number? I wonder, since it's a triple number, that would mean that square equals circle, and this would become irrelevant if it were a triple number. We definitely would know square equals circle, and so this would be a card that becomes irrelevant because of course square equals circle if you have a triple number. So I think for that reason we can sort of deduce that, yeah, it should be a double number, not a triple number. What else? Remember that because the sum cannot be smaller than 6, we sort of said that you can't have both triangle and square be small numbers. So maybe square could be either a 4 or a 5. And of course, we're trying to figure out this 3-digit solution so that it meets all the requirements of all our criteria cards. So why could a puzzle have criteria card be the number of 4s? If we did have 2 4s, it wouldn't necessarily mean that square and circle had to be the 4s. We do have a little bit of everything, triangle, square, and circle. But how are they interacting to get us that solution? I wonder if the sum of the first 2 digits is 6. We could have a double number, maybe something like 242, where even though we do have a sum of 6, and instead of having 2 4s, we have 2 2s, and so that would maybe mean that square could be 4. So if we know for sure square is 4, and the sum is 6, obviously that would mean that triangle is 2. And because we know there's a double number, question is it 2 4s or 2 2s? And this card will let us know that, yeah, maybe there's only 1 4. So let's try that out. Let's do 2 4 2 and see what becomes of that. Okay. Well, the whole reason I really created this proposal is because of criteria card A. So let's go ahead and test A. Okay, so we know that it is not equal to 4. So either we have a square value that's less than 4 or greater than 4. Okay, so we can actually cross out the number 4 out of everything. Okay, and let's update our notes to say that square should be either less than 4 or greater than 4. So square is either less than or greater than 4. So what would that mean if, say, square were greater than 4? Well, it'd mean that it'd be a 5. And how would that affect everything else? Well, let's go ahead and test. I think I'm going to retest D to see what the sum might be. Is it a 6 or is it not? Okay, so it is a sum of 6. Interesting. Okay, so let's go ahead and cross out the or and the greater than. So we know it's 6. So since square is not 4, that means that triangle cannot be 2, because that's a sum of 6. Okay. We haven't tested how many 4s there are. That would be interesting. I do have a single 4. We know there can be 3 4s, because obviously square is not a 4. So it can't be 3. I think that's all we can say. Remember, we're still dealing with a double number. So I wonder if it could be something like 3 3 4. Yeah, there's nothing that would prevent it from being 4 2. It could be even 4 2 2. That's a possibility. Let's go ahead. Let's test criteria card B, see what the count of the number 4s are. Okay, so it does not approve of a single 4. Okay, so again, obviously we can't have 3 4s. We could have 2 4s. So either there are no 4s or 2 4s. So let's phrase it that way in our notes, that there are either no 4s or 2 4s. Let's put it that way. Okay, so there are 2 4s. Well, it would be 4 2 4. So that would give us a 6. Let's see, what else can we... I think probably... Yeah, I think the next best thing would be to test C again. Oh no, we're done. That was the end of this round. Wow, that was quick. So we've already completed our 3 Turing tests for round 2. And I don't think we've really gotten any closer. Okay, well that does it for this round. Let's discuss again how we can construct a second or third round proposal. Okay, so again we are going with the idea that there is a double number, not a triple number. And so, and again we're thinking either there are no 4s or 2 4s. Well, let's see, if there are no 4s, then the sum that makes up 6 would have to be 2 odds. And let's see, we still have the fact that square could be equal to or greater than circle. Wow, there just seems to be too many possibilities. But again, we do know that we have a sum of 6. Let's see. So again, if there were 2 4s, the only way is to get 4 2 4. But I'm thinking that's too obvious, or that's too simple. So I'm thinking that there probably are no 4s, and we're going to have to add up 2 odds to get our 6 between triangle and square. And we do need 2 values. So it might be, and we also want to make sure that square is either equal to or greater than circle. So it could be something like maybe 511, or so square and circle were to be equal. I don't think, I just don't think that could be true, because there's nothing that really is constraining triangle to be one or the other. So it could be something like 155 or 511, or even 3 3. But of course, a 3 3 for square and circle would mean that triangle would also have to be 3 and be a triple number. So I don't think it's that they're going to be equal. So let's go with the premise that square has to be greater than circle. So maybe something like 151. Yeah, so it could be that square is going to be greater than 4. So that makes it a 5, which forces triangle to be 1. And then yeah, square is greater than circle. And there has to be a double. So let's go with 151 and see where that leads us. Okay, so yeah, let's go ahead and test A. Okay, so in fact it is not greater than 4. So that means that square has to be less than 4. Wow. Okay. So this is turning out to be a very interesting puzzle. Okay, so no 5, so we're dealing with 1, 2, or 3. So that means that triangle cannot be a 1 because it has nothing to add up to give us 6. So it could be 5 1, it could be 4 2, or 3 3. Okay. And I guess let's go ahead and test C. Again, incorrect. So I do have square is greater than circle, so it must be equal. So it's not greater than, it must be equal to. Well, very interesting development. So that means that circle cannot be 4 or 5, since we've already crossed out 4 and 5. Okay, and we still need a sum of 6. So we could still have that triple number in all threes. We could have 422. So this is interesting. Okay. Well, based on criteria card B, there seems to be no way to have another 4, because we already tested that in round 2 and it failed. So I believe we can cross out the 4 and therefore cross out the 2 for square, because that would give us a 6. And we could then cross out the other 2 because they are to be equal. So it can't be, so it looks like we are dealing with an all odd solution. And I don't think triangle can be 3, because if it were 3, well, again, I'm under the impression that it's not going to be a triple number. So it can't be triangle 3, because that would force square to be 3, which would then force circle to be 3. And I'm under the impression that it's not a triple number. So the only thing that's left is 511. And is there any way I can definitely, let's see, the only thing I can test is B, but we've already deduced that there are no 4s. What would you test? Even if it were to take a 4th round, oh, you know what? Let's go ahead and test E to complete it. Wow, that would be 9 tests. Yeah, I think I'm going to lose this one. I may get it right, but I'll still get it wrong, or lose, versus a Turing machine. So, yeah, let's go ahead and test E and verify that there's a double number. Okay, at least we know there's a double number. So yeah, so it's got to be 511, because again, like I mentioned, if triangle were 3, that forces square to be 3, which would force circle to be 3, and that would give you a triple number. So yeah, it's got to be 511. Okay, well, I feel confident about the solution. I just don't feel very comfortable in that it took me 9 questions to come to that conclusion. I don't know where I missed it, any efficiencies or whatnot. And I still haven't verified that that's a solution, but it looks like it could be. So let's go ahead and do 511 and see how we did. So 511. Okay, very good. Now let's see how we did versus a Turing machine. Well, we did 9 questions. So we did C, D, E, and then A, B, D, and then A, C, E. All right, so let's do that. C, D, E, and A, B, D. So C, D, E, we're all wrong. And then A, B, and I think we did D again. We did do D, and it was correct. And then we did AC, and both AC were wrong. But we finally got E to be correct. Yeah, wow. Lost by 2 questions. Not sure where I just totally missed it. Too many extra questions. Not sure. Okay, well, if you have any thoughts, please add them to the comments. Oops. And if you liked the video, of course, please do give it a thumbs up so that more people can find this channel. And if you don't want to miss out on any future videos, make sure to hit subscribe to be notified. Well, until next time, have a great one.